In this video, we will demonstrate diffraction and interference using lasers and handmade single and double slits. The setup includes lasers of various wavelengths, a single and double slit, clay holders, and a white background. The single slit is made from electrical tape adhered to a microscope slide to block light. A single or double slit is cut into the tape using a razor, which allows a small amount of light to pass through. A handmade set of slits is shown here. A microscopic image shows there is one tiny gap for a single slit and two tiny gaps that are very close together for a double slit. When light passes through a very small opening, approximately the size of a wavelength, like the aperture created by the slits, it bends and spreads out. This is called diffraction. When the light bends, the light waves become out of sync and the waves interfere with one another. This interference can be seen on a faraway screen as a diffraction pattern. Here is a pattern created by a single slit. The bright spots, called maxima, are where constructive interference is happening, and the dark spots, called minima, are where destructive interference is happening. A single slit creates one large maxima in the center and then alternates between minima and maxima on the edges as it fades out. This is the diffraction pattern created by a double slit. The single slit pattern is still there, but there is additional interference that creates even more maxima and minima. How much light bends depends on the size of the wavelength. Longer wavelengths, like red, diffract more. This means the maxima will be fewer and spread out. Shorter wavelengths, like violet, will diffract less, and the maxima will be many more and closer together. Think about where you might see diffraction.